Alright, so part 1B, the difference here is it wants a measured amount. 1A was just run whenever you push the button, stop and let it go. Part B wants it to dispense a 10.5-inch sheet of paper. Typically when in the classroom, we give you the lab sheet. The lab sheet, let's try that here too. Oops, get out of there. The lab sheet has dispenser right here. It has some markings on it. So from the bottom of the sheet of paper, the very bottom, up till this line labeled A right here, see it? That's 10.5 inches. So use your lab sheet to dispense, but being we're doing this distance learning, we can't. All right, so 10.5-inch sheet of paper. So how are we going to have this dispense that? Distance learning style. We want to have the button clicked, the motors will run on their own and stop at the 10.5-inch point. How do we do that? Okay, that's part of today's. So this says to dispense 10 sheet of paper. That's the line labeled A. Words. When you're done, all right, code it. So same kind of program as before. Difference is we don't want to have the motors start stop. So basically we're going to have not an until, but an until, can I write it in my stuff? Let's find out. Until bump. Let's just go grab it. I need my while code again. I want it to run over and over and over again. I wanted to have it an until bump. So I click the button. The motors are going to start. They're going to run for a little bit of time. And then they're going to stop. Right? Start, wait, stop. So I'll fix all this up, and I'll figure it out too about the time. So to make this here cooperate, I want to click, let it run, and have it stop at that point. But I can't use anything to measure because you're at home, I'm at home. Make it work, right? All right. So a little bit of science here first, a little math here. Okay, this is one of those STEM classes. So we're gonna use a little bit of math here to figure things out. So the motor speeds are basically all they are is how many revolutions per minute. So if I'm going 60 spins per minute, so in 1 minute it'll spin 60 times around. All right. So that, how many spins will it make in 1 second? Do we know? Right. If 60 spins happen in 1 minute, 1 spin per second, right? So right now I'm saying a spin at 60 spins per second speed for 7 seconds. Why those numbers? Just because I know in my head, 1 second, 1 spin. 2 seconds, it'll have spun twice. 3 seconds, it'll spun 3 times. So in 7 seconds, it'll have spun 7 times, right? And my theory is, this is a 7-to-1 gear ratio. It takes 7 spins to make one. So wouldn't 7 seconds give the motor 7 spins, but give this wheel only 1 spin? Let's find out. I'm going to mark this with some tape. Okay, mark it with tape. See it? There it is. So my thought is, if I do this, it should spin 1 full lap. Let's find out. Compile program, not going to save it. Download the robot, not going to save it. and we will start. So here's my thought. The click happens, motor starts at this speed for that long. It should make one full lap, but it might not. We'll find out. You ready? Here we go. What happened there, I wonder? So, didn't quite work, huh? What if I know what we're going to do. I'm going to stopwatch. I'm going to time this for one full lap. I'll be right back. Stopwatch. Where's stopwatch? I'll find a stopwatch. All right. Got a stopwatch. So I'm going to try timing this for one full lap. I'm going to start a stopwatch when this tape is vertical, and I'll stop it when it's vertical. Okay? Try this again. Now. Stop. And about 4.05 seconds. Try that again. Make sure it wasn't just an accident. From top to top. So top. Top. 4.03. It's pretty consistent. So my guess is I'm going to have to stop this. Now it's hard to see. Stop this and say, let's run at 60 for 4 seconds. Now let's try it once. Download robot. Not going to save it. And then run it again. So now tape should go from pointing to the wheel to pointing to the wheel all in one click. Think so? Let's find out. Ah, look at that. Okay, so now we got to figure out what's going to be my actual time I need to use to build this in my code. Let us find out. All right. Pencil. Got one. Let's oops, gotta close this, scroll down for some blank space. Scoot this over here for now. And then let's figure this out. So here's the math. Right now, I measured the wheel, this wheel here, I measured it, and the circumference to that wheel is 13 inches. So 13-inch circumference. That's one full measurement around 13 inches. So right now, in 4 seconds, we're making 13 inches of distance. So what time do I need to make 10.5? How do I figure that out? So in 4 seconds, I get 13 inches, but I want to figure out the time I need to only get 10.5 inches. How do we solve for x? (10.5) times 4 divided by 13, you think? And multiply those two. Divide by that guy. Let's try it once. So, if I go calculator, if I do 10.5 times 4, of course it's 40. Get out of there. 10.5 times 4, 42, divided by 13 equals 3.23. 3.23. So, let's try it once. Let's go back to my program. Oops. And let's go 3.23 seconds. Stop the program. Download the robot. Not going to save it. And I'll try it again. So now, how much is 10.5 inches of 13? Well, I don't know exactly, but if this is 13 inches, what's 13? What's 13 divided by 4? 13 divided by 4. 3 1/4. So if I turn the wheel, this would be 3 1/4. Plus 3 1/4 is 6 1/2, right? Plus 3 1/4 is 7, 8, 9 3/4. So the tape should stop somewhere right about the 1 o'clock time frame, right? The 1 o'clock time frame. Let's try it once. I push start, push click. That's not bad, is it? Not bad at all. So that's kind of how we code that paper towel dispenser. We use the wheel diameter of 13 inches. We use a constant speed of 60 spins per second. Why is it going faster than what I had thought? Because I got a little bit bigger battery pack going back here. See it back here? Bigger battery pack. It's running a little bit more juice than the motor's like, but so maybe it's spinning faster. So maybe I should tone it down a little bit. So we found out, we timed it to do 1 full lap, did the math to figure out what we wanted. I think we're pretty close. So there's the part 1B of the lab. 1B of the lab.